Good day, stats students. So today we're going to talk about Chapter 5, Probability. Now, if you pick up a lot of textbooks, you're going to see an entire chapter dedicated to probability. And what happens is that these authors of these textbooks go into these crazy scenarios. You know, they say, okay, there's 20 marbles in the bag, and 5 are red, and 10 are blue, and 4 are yellow, and 1's white. What's the probability of drawing a white one, then a red one, then another red one, and then a blue one? And we're not doing that, okay? Sure, those are nice things to know if you are going to become a statistician and to really understand all these different scenarios with regards to probability. But we're not trying to make you into statisticians. We want you to understand that probability is a tool that we use in inferential statistics. So we don't need you to be able to calculate all those scenarios, okay? We want you to be able to understand probability so you can use them in problems, okay? Now you will calculate some probabilities, but they're going to be based upon tables and using the computer and things like that, instead of trying to come up with these probabilities for these crazy scenarios, all right? And so, what is probability? Probability is the chance that some event will occur. And I have to stress this, that probabilities are always calculated in the long run. And so, what does that mean? Well, let's say that our job is to assign a probability of a field goal kicker. So we're talking about football, American football, of making a 40-yard field goal. All right. Now, if you, by the way, if you know nothing about football, all right, and I've had students come up to me and say, I don't know anything of what you're talking about. Well, okay, watch this, all right? Watch this YouTube video and take a look at what we're talking about, all right? And honestly, you could apply this to anything. It really doesn't matter. So just about anything that you're trying to assign a probability to that isn't a game of chance, all right? So so our job is to assign probability of a field goal kicker of making a 40-yard field goal, all right? So let me ask you this. Do you think that you can just look at 5 of the kicker's attempts and then be able to calculate the probability of him making a 40-yard field goal? Just 5? What do you think? Probably not. What do you think you're going to have to do? You're probably going to have to look at more than just 5, okay? And that's what I'm talking about. Probabilities are, to calculate probabilities, all right, you have to do it in the long run, okay? You have to come up with a long-term relative frequency for it, all right? And so, no, you to answer this question, you have to have more than 5 trials, right? So, let's say that you actually do know what the probability is in the long run. Then you can take whatever it was in the long run and then apply it, the probability in the short term, okay? So, for instance, let's go back to our field goal kicker. Let's assume the kicker has attempted 500 40-yard field goals between games and practice, and he made 80% of them. Now, we have so it wasn't in the short term, okay? It wasn't in the short term. We just didn't do 5, okay? We did it in the long term. So we just didn't have 5 trials, all right? We had, 500, all right? Now we have a pretty good idea of how often he makes a 40-yard field goal, okay? And so, once we understand what the long-term consequences are here, what the long-term probabilities are, we can go ahead and apply this to the short term, all right? And so let me get rid of my chicken scratch here. So let's see what it says here. It says here, then we can say that the probability of him making just one field goal from 40 yards is about 80%. And I said about 80% because technically, in a very technical sense, okay, we would have to have him kick more than just 500. We would have to have him kick several more, and I'll just leave it as several more, okay, to actually figure out the exact probability. But the larger the sample size, the closer the probability will be to what it actually should be, okay? So after 500 trials, if it turned out to be 80, well, then it's going to be about 80%, okay, of him making one of those field goals. So notice what we did. We took the long run chance of things happening and then saying, okay, for one trial then, for one field goal at 40 yards, okay, it's about 80%. Okay? All right. Probabilities. What values can they assume? They can assume between, I shouldn't say between, they can assume from 0 to 1. So remember, this is just saying, since probability is in between these two numbers, this is our mathematical way of saying probability is what? Can be numbers from 0 to 1, and it includes 0 and includes 1. You can, probabilities can also be stated as a percentage. Okay, and so what does 0% translate to? Excuse me, what does 0 translate to? 0%. What does 1 translate to? 100% as far as a percentage goes. All right, so here, if you state it like this, this means that probably it's going to be stated as a decimal. All right, something like that. So that can be a valid probability, 0.304. Okay, and this one obviously a percentage. This one I suppose you could also say like a half, okay, fraction also, but generally speaking, we're not going to be working with fractions too often. I can think of just one scenario that maybe in chapter 6 that we're going to see some fractions, but for the most part, decimals, okay, proportions, or percentages with regards to stating probabilities. Now, so not alone does this tell us what values probabilities can take on, it also tells us what values probabilities cannot assume. Okay, so if probabilities can only go from 0 to 1, probabilities cannot be what? Greater than 1, nor can they be what? Negative. So if you calculate a probability that's negative, you made a mistake. You need to stop, okay, and say, oh, okay, I made a mistake. Don't leave a probability as negative, all right? Don't leave it as your answer. It's automatically going to be wrong. Don't leave your answer for a probability greater than 1. It will be marked wrong. It has to be, because it can't be right. All right, and so probabilities cannot be negative, and they cannot be greater than 1. All right, so know some notation with regards to probability. So a lot of times what we do is we define some sort of an event with a capital letter, and I'll give you an example here. Let's say we flip a coin once. What's the probability of getting tails? All right, so all we're doing is flipping a coin once. What's the probability of getting tails? And so we use a capital letter to stand for the event. And so we might say A, okay, so we're using a capital letter. Let A be equal to getting tails on one flip of a fair coin. Okay? And then, if we wanted to show some notation with regards to the probability of event A, we could write it as capital P and in parentheses A, our event. All right? And so probability, whenever you see a capital P in statistics, we're probably talking about probability. Okay? And then if you have parentheses after that and some sort of letter, or maybe even all these words inside of there, we have defined some sort of event, and it's the probability of that happening. Okay? So we could then say that this stands for the probability of getting tails on one flip of a coin. There's other ways of doing this, but that's one way. But certainly note that events can be defined with a letter and probability with a capital P. All right, so let's do some interpretation of probabilities. So the probability of some event will occur, let's say it turns out to be 0. What does that mean? Okay, so let's go to the one extreme. The one extreme probabilities of some event will occur 0. What does that mean? It's a very concrete thing. This event will not occur. All right, it cannot occur. If it's 0, it will not occur. It can't happen. All right, it's a very concrete thing. How about the probability of some event will occur is equal to 1? So we go to the opposite extreme. What does that mean? The event will occur. Okay? It's going to occur. All right? It has to. All right? It has a probability of 1. So these are very concrete things. All right? It will not occur. It will occur. 0, 1. All right? very concrete. But we have to interpret everything else in between, and so let's go into the middle. So let's say the probability of some event will occur is equal to 0.5. What does that mean? Well, the chance that the event will occur is the same as that it won't. All right, because this is the chance that it will occur, and so if it's right in the middle, well, okay, you got a 50-50 proposition at that point, and the chances of it occurring or not occurring is exactly the same. All right, so between those 3 points, we should be able to interpret all the other probabilities. All right. So the probability of some event will occur, let's say it's less than 0.05, less than 0.05. This is what we call a rare event, okay? And so it's not 0, okay? And so, by the way, I probably should have said that the probability is greater than 0 here, but less than 0.05, all right? I probably should have updated some notation there. But that's what we're talking about. It's greater than 0. Okay, it's greater than 0, but less than 0.05. Okay, so what does that mean? Well, the chance that the event will occur is small. It could happen, but it is not likely to occur. All right, it's not likely to occur. So it is above 0, so it can occur. All right, but it's less than 0.05. That's a rare event. Okay, that's a rare event. About the opposite, and let's throw this in here that it can't go all the way up to 1, and so it is less than 1, okay, but greater than 0.95 here. So it's greater than 0.95 but less than 1. All right, and so the probability of some event is like that. This is supposed to be the chance that the event will occur is large. It most likely will happen, but it doesn't have to. Okay, so like this one right here, let's go back to a rare event. We hear about people winning the lottery, right? Well, the chance of any one ticket winning the lottery is very, very small, okay? But if enough people play, it's bound that somebody will win, okay? So that's a rare event, all right? The probability of some event will occur, all right? And so let's see here. How about I don't know, let's go to some place that's really sunny like Hawaii. The probability it's going to be sunny at least part of the day in Hawaii is maybe greater than 0.95. All right, maybe it's 0.98 or something. Okay, and so so if the chance that the event will occur is large, it will most likely happen, but it doesn't have to. Okay, hopefully that gives you some ideas there on how to navigate through probability. Okay, the last thing that I want to talk about are complements, and that's we see complements throughout the semester, all right, and so it's good to bring them up now, all right, because it has to do with probability. So complements, these are two events that could happen for some defined situation, and their probabilities add to 1 or 100%, okay? And let's not make this too terribly difficult. Let's define the situation. We'll just say weather, okay? And so with that, if I told you the probability that it's going to rain today is equal to 80%, what's the probability that it's not going to rain? Well, if the probability it's going to rain is 80%, you know these two things are complements to one another, all right? And that means that since you know that they have to add up to 100%, if you know the one, you automatically know the other one. They're complements to one another. So if I told you the probability is going to rain today is 80%, we know that the probability that it will not rain today is 100% minus 80. All right, to get 20% now, these two things add up to 100%. Okay, and so there we go. All right, complements. So we see complements a couple of times throughout the semester. All right, that's what we want you to know about probability. Okay, and so thank you for your time.